In topic 2, we are going to be solving a system of linear equations graphically. So we're going to graph linear equations and then we're going to find the solution of them. Now, solving a system of equations means finding where the two lines meet or where they touch or cross each other. So when we graph these two lines, there's going to be one coordinate point where they both meet, and that's going to be the solution for the system. So let's start with example 1. Solve this linear system. Verify your answer. So they give us two equations of lines here, and they're both in slope-intercept form. So for this one, we have that the slope is -5/3, so that's the rise over run. And then we also have the y-intercept, which is -2. So let's quickly graph that line. So we're going to start by placing our y-intercept at -2. And then we are going to do our rise and run from there. So we are going to rise 5 in the negative direction. So 1, 2, 3, 4, 5, and then run 3 in the positive direction. 1, 2, 3. So here would be another point. And then I'm going to do the opposite of that. So I'm going to now rise 5 in the positive direction. 4, 5, and then I'm going to run 3 in the negative direction. So that would land us right here. So keep doing your rise and run in order to plot your entire line. Once you have enough points, take your ruler and line them all up. And I don't have a ruler on my tablet, so please, I'm trusting you to use a ruler here. And you're going to connect these dots in a nice, perfect, straight line. And then make sure you put your line going off forever off of the graph and put those little arrowheads on there. So if you have two different color pens to do this, that would be nice. If not, that is totally okay. Just make sure that you label your equation after you plot it. So I'm going to put y is equal to -3/2 x minus 2. And now I'm going to do the same thing for our second equation. So for this one, we have that the slope is equal to -1/2, and that's the rise over run. And then this time our y-intercept is +5. So let's start by putting our y-intercept on the graph. That would be right there. And then we are going to rise -1 and run 2 in the positive direction. And then we're going to keep doing that to continue our line as far as we can go on the graph. And then I'm going to do the opposite. So I'm going to rise 1 in the positive direction, and then I'm going to run 2 in the negative direction. So that would land us here, and I'm going to keep doing that as well to extend our line the other direction. So there we go. I drew this line on and I labeled the equation of it right beside it. And make sure, like I said, you use a ruler because clearly my line isn't very straight there, but that's okay. We'll make do with it. So now we look at our graph and we look at where the two lines intersect, or where they cross each other. So they cross each other right at this point. So that coordinate there is at -6 and then +8. So that's the x and y of that point. So we're just going to write here that the lines intersect at -6, 8. So that there is our solution for this system of equations. So now whenever you find the solution for a system of equations, you should make sure you verify that it is correct. It does say at the top of this question to verify your answer. Sometimes it won't say that, sometimes it will. And whenever you see verify, you know you have to do the left-hand side, right-hand side table. So you're going to verify by plugging in each equation. X is equal to -6 and y is equal to 8 because that's our solution. So I'm going to do my left-hand side, right-hand side for each of the equations, and I'm going to cut ahead so you can see what that looks like after it's done. All right, so I took both of the equations that we had at the beginning of the question, and I did a t-chart for each of them with the left-hand side, right-hand side, and then I plugged in x as -6 in both of them and y as 8 in both of them, and I worked my way down the sides of the t-chart, and at the end I got 8 and 8 on both sides of the left-hand side and right-hand side of the chart. Therefore, our solution is correct. So I'm just going to put here, therefore, -6, 8 is the solution. And that's the end of that question. So let's look at the next one. So in the next one, it says solve the linear system, verify your answer. And you'll notice here that they did not give our equations in any type of form that we are used to. So they're not in slope-intercept form and they're not in slope-point form. So what I would do here is change both equations into slope-intercept form. All right, so I'm going to label my equations number 1 and number 2 just to help us stay organized. And I'm going to start by changing number 1 into slope-intercept form. So remember, with slope-intercept form, you need y is equal to the rest of the equation. So we need to move all the terms that aren't y onto the other side of the equal sign, and that would just be the x at this point. So this would turn into y is equal to 8 minus x, and then we would switch it around so that the x comes first. So y is equal to negative x plus 8. So now it's in slope-intercept form, and we can see that the slope is negative 1, and the y-intercept is positive 8. And now let's do the exact same thing to the second equation. Okay, so our first step is to move all the terms that don't include y to the other side of the equal sign. So then we're going to have negative 2y is equal to negative 3x plus 14. And now we need to get that y all by itself. So in order to do that, we need to divide everything by negative 2. So I'm going to divide everything, or every term, by negative 2, because that's going to cancel out that negative 2 beside the y. So then we're going to have y is equal to negative 3 over negative 2x. So remember, if there's a negative sign on top of a negative sign, those two cancel out. So really, this just leaves us with 3 over 2x. And then we have 14 divided by negative 2, and that would just be negative 7. So now we have this in slope-intercept form. We have that the slope is 3 over 2, and that we have the y-intercept is negative 7. So now that these are in slope-intercept form, we can easily graph them on our chart right below here. So I'm going to take a second and graph both of these. Remember, we start by plotting the y-intercept. So here I'll do the first one in pink. So we put the y-intercept at 8. And then we're going to do our slope, which is negative 1. Now, since this slope isn't in a fraction form, we can't really see the rise over run. But remember, we can just make it into a fraction by doing negative 1 over 1, because that would be our rise over run. So I'm going to rise negative 1 and run positive 1. So that would leave me right here, and so on. So I'm going to continue this line and connect all the dots, and then I'm going to do the exact same thing to the orange equation, or number 2. Okay, so I graphed both of these equations, and make sure when you're graphing them that you're using a ruler so your lines are a lot more straight than mine are. Don't forget the arrowheads, and I also labeled each equation on the graph. So now the solution for these are where the two lines meet, which would be right at this point, and that coordinate is 6, 2. So that there is the solution. So I'm just going to put that the lines intersect at 6, 2. So that is the solution. And we need to verify that this solution is correct. So right below here, I'm going to put verify. So then we have to do our left-hand side, right-hand side charts for both of the equations. Now, when you're verifying, make sure you use the original equations that they gave you. So don't use these slope-intercept forms. Use the ones that they gave us up here in order to verify, because that's how you'll for sure know you have your answer correct. If you made a mistake in the slope-intercept forms, then you won't know if your solution's actually correct or not. So the first one, equation number 1, I'll put in the first little chart here. So I'll label this as number 1, and then we'll plug in our equation. So the left-hand side of that one is x plus y, and the right-hand side is 8. So then we're going to plug in 6 for our x and 2 for our y. So we should have 6 plus 2, and then 8. So we got 8 on both sides of the equal sign. Left-hand side is equal to right-hand side. And now let's verify our second equation. So number 2, we have 3x minus 2y on the left and 14 on the right. So now we're going to plug in 6 in the x spot and 2 in the y spot, and we're just going to follow BEDMAS here to see if it equals. the other side, and it sure does. Left-hand side is equal to right-hand side. So we know for sure that our solution is correct. So I'm just going to add a little side note, and you might want to add this for yourself as well, to use the original equations to verify. So do not use the ones that you switched. So there's one more example that we have, example 3, very similar to the last one. We need to solve this linear system by graphing it. Again, you'll notice that our equations are not in slope-intercept form. So our first step again is to change both equations to slope-intercept form. So again, I labeled our equations 1 and 2, and now we're going to switch them to slope-intercept form. So let's start off with number 1. We have 0 is equal to negative 3x minus y minus 3. So in order to get it to slope-intercept form, we need y is equal to the rest of the equation. So actually, this one's really easy to switch to slope-intercept form. All we have to do is move this y to the other side of the equal sign, because then we'll have y is equal to the rest of the equation. So if we do that, we would have y, and it would turn positive when we move it to the other side, so that's exactly what we're looking for, is equal to negative 3x minus 3. So that there is our slope-intercept form of the equation. And now let's do the same thing for the number 2. We have 2y plus x is equal to 4. So I would start by moving that x over to get the y term all by itself. So then we'd have 2y is equal to negative x plus 4. And then we're going to divide everything by 2 in order to get the y all by itself. So then we have y is equal to negative x over 2, or negative 1x over 2. Remember, there's an invisible 1 there. And then 4 divided by 2 is just 2. So there are our two equations in slope-intercept form. So now we're going to use those in order to graph the lines. So I'm going to start with my pink one, start by putting that y-intercept at negative 3. This here is the y-intercept, so that's negative 3. And then our slope for this one is negative 3 over 1. So we're going to rise negative 3. So I'm going to go downwards 3, 1, 2, 3, and run 1 in the positive direction. And we'll continue that pattern like so. And then we can also switch this around where it's 3 over negative 1. So I'm going to rise 3, 1, 2, 3. And then we're going to run negative 1, so that would land us here. So continue that rise and run to make your line nice and straight and go along the entire graph. Make sure you use a ruler. Okay, and I'm going to do the same thing for our equation number 2, the orange one. So I'm going to start by plotting our y-intercept, which is at plus 2. And then we're going to do our rise and run. So our rise this time is negative 1, and our run is 2. So that would bring us here. Then rise negative 1, run 2, and so on. So keep doing that. And then we can also do the opposite direction where we rise 1 and run negative 2. So we're going to rise 1 and run negative 2. And right there you can see where our solution is going to be. But continue graphing this entire line. So once you have that line perfectly graphed, then we can see that our solution is right here at negative 2, positive 3. So negative 2, positive 3 is the solution. So I'm just going to write that the lines intersect at negative 2, positive 3. So that is the solution. And again, we are going to verify our answer with the original equations, because again, we had to switch our equations around into slope-intercept form. So verify with original equations. So I'm going to do that, and then I'll hop ahead to show you the final verification of it all. All right, so here are the verifications for both equations. So this is number 2 here, and then we have number 1 over here, and you can see that we eventually get both the left-hand side and the right-hand side for both of them equaling each other. So we know for sure that negative 2, 3 is our solution for this system of equations.